Hey everyone, Matthew here from Red Flyer Coding, and today I'm bringing you guys episode number 5 of our platformer game development tutorial series. In the last video we left off building our map right here, but our player can't actually collide with any of our objects yet. So in today's video we'll be making the collision system, and by the end the player will be able to sit on the ground and collide with the walls, and everything's going to work really smoothly. We're still able to jump unlimited times. We'll set that up in the next video, the proper jumping. But we're gonna have the collisions in this video, so we can have our player hitting the wall, hitting the ground, hitting the ceiling, but there's no ceiling for them to interact with, but that would work as well. So let's get into VS Code. And before we actually do that, I want to show you guys a quick demonstration with MS Paint, because the way that we're going to handle collisions in this game is we're going to have a rectangle around the player, and we're going to have rectangles around each one of these walls. And then the way it's going to work is we have to check if the rectangles are intersecting, and if they are, we're going to do something based on that. So we need some code that's going to check if rectangles are intersecting for us, and I want to explain to you guys how this works. My first thought when making code to check rectangle intersection was to just see if they share like a common x value and maybe a common y value, then they do intersect. But that takes a lot of code to actually check for, and I haven't really considered the logic of that too much. I think it's possible, but I realized quickly that there's a much better solution. So the one that we'll actually be using is checking when it is not intersecting and then kind of working backwards from there. And the way we do that is if this is our wall, this red rectangle, and the green rectangle is our player, there's a few things that we can check to see if it's definitely not intersecting. The first one is if the left edge of the player is farther to the right than the right edge of the wall, then no matter how the player moves up and down, it's never ever going to intersect with this rectangle. So that's a really easy thing to check for. If the x position of the player, because remember our coordinate system starts in the top left, if the x position of the player is greater than the x position of the wall plus the width of the wall, then we know that they're not intersecting, no matter what. Because we know the x position and the y position is irrelevant. Regardless if you can move this up to infinity or down to infinity, it's never going to intersect. And that works on all four of the sides. So with this side, if the x position of the player plus the width of the player is greater than the x position of the wall, or excuse me, is less than the x position of the wall, then we know that this is going to be to the left. So no matter how you change the y coordinate, it's never going to intersect. Same thing with the top and the bottom. Hopefully you guys understand it by now. But if the y position of the player plus the height of the player is less than the y position of the wall, remember y coordinates increase as you move down, then they will never intersect. And finally, if the y position of the wall plus the height of the wall is less than the y position of the player, that means that the player is below the wall. So we can check for all four of those, and if none of those are true, then they have to intersect, because if it's not to the right of it, it's not above it, it's not to the left, and it's not below, then that means that it must be like inside here, or maybe it's tiny and inside the middle of the wall, but we won't really have that case for our game. So that's a pretty easy thing to check for, but one more thing is we actually can't just say greater than, because if we say greater than, then technically this would mean not intersecting, because right now the x-coordinate of the player and the x-coordinate of the wall plus the width of the wall is equal to each other. So if we just say greater than, this will not be an intersection, which means that right now the player is standing in the wall, so we don't really want that. So actually we have to say greater than or equal to, and it'll be right there instead. So if we just say greater than, it'll be there. Greater than or equal to will create proper collisions. That way our player isn't like just barely standing inside of the wall. Okay, MS Paint is actually pretty useful for that. Let's close out of that and get into VS Code. The first thing that we're going to do is go in our index.js file, and we're actually going to make the check intersection function within this file, because remember, we can still access those from our player, and you never know, we might need to use these sometime in the future. If we have like maybe projectiles, like in Mario he can shoot fire, maybe the fire will have to see if it's intersecting with a wall, and then it bounces. That's how it works in Mario, is the fire bounces when it hits the ground, or I think a wall too. Maybe it just dies when it hits a wall. But it has to collide with it either way. So that's why we're going to keep this function in here. And it would work a little different if we had fire and it was round. You'd use like kind of a radius instead, but it's the same idea. So we're going to say function check intersection, and then we're going to take two parameters, R1 and R2. And those are both going to be objects that have an x, a y, a width, and a height. and we'll be, oh, we need a comma here, and we'll be checking if they are intersecting. If they do intersect, we're going to return true, and else we will return false. So we're going to say if r1.x is greater than r2.x plus r2.width, and this is just using that idea that I just showed you guys, then we're going to return false. And then we're going to say else if r1.x plus r1.width is less than r2.x. And remember, we actually need to make these equal then signs. I forgot the equal then because of the explanation I just showed you. Again, we don't want our player just barely standing in the wall. So we're going to say greater than or equal to and less than or equal to. Then we will return false again. Else if r1.y is greater than or equal to r2.y plus r2.height. Return false. And finally, we'll say else if r1.y plus r1.height is less than or equal to r2.y. Return false. And finally, if none of these happen, then we'll say else return true. So this is just going to check each one of these cases that we just talked about. So if any of these are true, then that means that there's no possible way that the rectangles could intersect, so we will return false. But if we check all 4 of them and none of them are true, then the rectangles must be intersecting, so then we will return true. Just down at the bottom down here. Sorry, my nose has been running all day, but I think we'll be okay. Okay, so now I think we're done with index.js. I'm going to control save that, and everything else should be handled within our player. Yep, okay. So let's move back to our player here, and we have our step event that we created in the previous episode. And really quick, there is one change that we want to do, and I realized when I was troubleshooting this, I was having some problems trying to get it to work for a while, and I realized that we don't want our x and y coordinates to be decimals. We want them only to be whole numbers because it makes the collision checking much simpler and much more smooth. So within our little function here, or our comment, I guess, our correct speed comment, we're going to add a little bit more to that to make sure that none of our speed values are decimals. Because if we don't have any of our speed values being decimals, the x value can never become a decimal because it's just a function of adding. We add speed to x every time. And x starts as a whole number, so as long as we're adding and subtracting whole numbers to it, this will always remain as a whole number. So right below here, we're going to say if this dot x speed is greater than 0, this dot x speed is equal to math.floor this dot x speed. Now you might be curious why we have to say this dot x speed is greater than 0. It's because I really don't like math.floor. I wish it would just round down. And if there's another way to round down, let me know in the comments down below. I didn't look too hard, to be honest, because this isn't much extra code. It's just a little bit extra. But if there's another way to do it, please let me know. But the problem with this is if you have a negative number, so if x speed is less than 0 and you use math.floor, it'll actually like round up. So if you have negative 0.25, it'll round it to negative 1, which is super annoying because then your player just keeps moving forever when you move to the left. So we just have to have an if, and then we're going to say else this dot x speed is equal to math.ceil this dot x speed. If you have math.ceil on a positive number, it'll round it up again. But for negative numbers, it rounds it down. It's really annoying in my opinion. I wish it was different. But I don't think there's a different way. But if there is, please let me know. And then we don't have to worry about, we can just have an else. Because if it's 0, and then 0 rounds to nothing anyways. So that doesn't really matter. So you don't have to worry about any errors there. And then we'll do the same thing and just make this y speed. Y speed, y speed, y speed, y speed. So now if we save this and go into our game here, our movement still looks the same. We maybe suffer from like a tiny bit on the acceleration. It's maybe a little bit less smooth, but it's going to help our collisions a lot in the long run. So it's definitely a worthy sacrifice. And you could modify the collision code if you really wanted to handle decimals, but it would just be much more complicated. Okay, there we are. So now we're going to make some collision rectangles. As I mentioned, we're going to make rectangles around the player, and we're going to treat all the walls as rectangles as well. So right here, we're going to say horizontal collision rect and vertical collision rect. So what these are going to look like is they're going to be let horizontal, nope, I want that to be lowercase. Horizontal rect is equal to an object, and it has an x value of this dot x plus this dot x speed. And the reason for this is because at this point in our code, we have our x speed. It was already decided by our key inputs up here, but we haven't actually moved the player yet, because if we wait until the player is inside of the wall, and then we check, oh, is the player colliding with the wall? If they are, stop them. Then they're just going to get stuck in the wall. So we have to be proactive here. And before we actually move the player, we're going to see, will this movement put the player in the wall? And if it does, let's prevent that from happening. So that's what we'll be doing here. This actually has to be a comma, not a semicolon. Then we're going to say y this dot y, width is this dot width, and height is this dot height. And then this seems like a lot of variables, but the reason we're setting it up like this is if you wanted to make your player a different size, you absolutely could. If you wanted to make the borders a different size, you absolutely could do that as well. So that's the cool thing about this system, is it's going to work for any size player or border as long as they're rectangular. And we might actually eventually add like a kind of a character to our player, so it's not just a box, but we'll probably end up still using a rectangular collision mask, just because if you want to use like a unique collision mask, that is a lot more work. That's way more complicated, and we probably won't get into that for this series, so we'll be sticking with rectangular collision masks. So now we have to make the vertical one. So we're going to say vertical rect is equal to x this dot x, y this dot y plus this dot y speed. And these are broken up into two different rectangles because remember we have an x speed and a y speed. So this one will be checking if our x movement is going to put the player into a wall and then prevent that from happening. This one will be checking if our y movement is going to put the player into a wall and then prevent that from happening. And then width this dot width, height this dot height. Just like that. Okay, let me scroll down in my code a little bit here. Cool. Height, oh, that has to be a colon, not a semicolon. There we are. Okay, so now we're going to check for intersections. Okay, so we're gonna make a for loop. You guys know I don't like for each. For I is equal to 0, I is less than borders dot length, I plus plus. So this will step through our entire borders array that we have in our index.js up here, and this is where we're storing all those border objects. And remember, they could be different things. Maybe one of them is a wall, one of them is the ground, but this will work for all of those at the same time, which is nice about this system. So first we're going to say we're going to make another let, and it's going to be let border rect is an object, and it's going to have x borders I dot x, y borders I dot y, width borders I dot width, and height borders I dot height. So this is just going to make sure that the border that we're currently on, as we step through all of the borders, will apply all of its attributes to border rect. And in the future, if we end up making this game side-scrolling, we will optimize it where it only checks for any of the borders that are maybe on the screen or within like 500 pixels of the player. Because we don't, eventually if we have like hundreds of borders in a level, we don't want to have to step through every single one of those. That'll probably make our game laggy and slow. So we will optimize this in the future. Don't worry about that. But here we are, we're going to create border rect. And now that we've created that, we're going to have an if statement. So we're going to say if check intersection, and we're going to pass through horizontal rect and border rect. Just like that. Remember, horizontal rect is the one with our x speed, and border rect is the one that we just created. So if that happens, I have a console log statement that I was using for testing in my solution code. We don't need that anymore. Okay. Then we're going to say while check intersection, horizontal rect, border rect. And then we're going to say horizontal rect dot x is minus equal to math dot sign this dot x speed. Okay, so this is kind of a lot. But the problem with if we just check for an intersection, and then if there is an intersection, we stop the player, is then our player is going to be stopping really far out from the wall. I'll actually show you guys this. Let's comment these out. And we will end up having this at the bottom anyways. So we'll say this dot x speed is equal to 0. Okay, So if we go here, and if we try and go into the wall, you can see that it works great sometimes, but sometimes we get stuck farther out from the wall than we're supposed to be. It's working convincingly good, convincingly well right now. Also, this is difficult for me to show you guys because we don't have the vertical one set up yet, but you can see that we kind of get stuck outside of the wall sometimes, which isn't really what we want. Again, we got stuck right there. We want to make sure we're flush up against the wall every time like that. So we're going to do something a little bit different. I guess I should add the vertical one first so that way you guys can see this a little bit better. Oops, didn't mean to select all those. Okay, so let's just copy paste this. We're going to select that. And we're going to paste it right there. And then this time we're just going to change it to Y speed. And you guys can copy this along because this will end up being our actual code, just with a little bit of changes. This time we're going to check intersection for vertical rect, and we're going to set Y speed is equal to 0. So now you guys should be able to see it more clearly. It's not going to be perfect. It's actually not too bad, but the reason for that is because I'm still holding down A. As long as you hold it down, see, it's kind of like a smooth stop into the wall. So if you really wanted it to be like this, I mean, you could. But the problem is if I let go of A before we hit the wall, then sometimes we're going to get a weird collision like that or like that. It's not going to work perfectly like that. That's a big one. And that just looks kind of funny, especially if that happens on the ground too, which I guess it won't because gravity is going to keep pushing us down until we actually hit that wall. It's not ideal is what I'm saying. It's okay, but it's not perfect. So we're going to make it a little bit better with this while loop. And we're going to say, while there's still an intersection between horizontal rect and border rect, we're actually going to move horizontal rect away from the wall. So math.sign is just used, not to be confused with sign without the G, which is like the circle thing. Sign with the G is just positive or negative. The circle thing. Oh, that's funny. Okay. So math.sign is going to tell us if it's positive or negative. So if our x speed is positive and we're moving to the right, then we're going to subtract 1 from horizontal rect. So horizontal rect will be in the wall, and then we're going to keep moving it out of the wall until there is no longer an intersection between horizontal rect and border rect. And then all we have to do is we have to say this dot x is equal to horizontal rect dot x. And then we're going to set x speed equal to 0. And what that's going to do is every single time it's going to put our player 1 pixel away from the wall, which might seem weird, like we're teleporting our player around, but we're not, because they would have gone into the wall, so they would have gone farther. So it's really just restricting their movement by a few pixels so that they collide with the wall perfectly every single time. And we're going to do the same thing here. Well, check intersection vertical rect, horizontal rect dot, oh no, vertical rect dot y, make sure I'm doing this right, yep, is minus equal to math.sign this dot y speed. Same idea, if we're in the wall, we're going to keep moving away from the wall until we're no longer within the wall. And then we're going to set y speed equal to 0, and this dot y is equal to vertical rect dot y. Okay, so let's save that, and let's go back to our tutorial here. Oh, I think we spawned inside the wall. Let's move our spawn point over. I'm not sure what just happened there. I think we spawned inside the wall, and that's why it gave us an error. I forgot to move the spawn point. Let's move our player to 300, 200. That'll let them spawn a little bit higher. And if you do get stuck in a wall, the while loops will just crash your game, which is not super fun. But let's copy this and put this here and then change this to tutorial. And now if we're spawning, oh, jeez. That's not what I meant to do. There we are. Okay, and oh yeah, no, we clearly have an error here. Okay, well, give me a second to check this out, and I'll get back to you guys when it's fixed. Oh, I already see the error. It's pretty simple. That's vertical rect.yx, which does not exist, so that's just going to give us nothing. So it's never actually changing, which is why we're just stuck in this while loop forever, because it's never actually changing vertical rect, which means that this while loop can never end. So let's change that to Y. Now it should work fine. Of course, we're stuck in the endless while loop again. Alright guys, I got to reopen finally. And now that we fixed that endless while loop, it looks like we have our seamless collision system all set up. So in the next video, we'll be making it so you can't just fly. We'll have to make sure that they're on the ground to jump, and we'll probably be increasing the jumping power because it's hard to tell exactly what one key press is, but it doesn't seem like a very strong jump. So we'll be making that much higher, and then we'll be adding maybe some enemies or some power-ups, maybe some textures to the game, a better background than just a white screen. This is where, if you guys want to start dropping a comment and letting me know what you want to see in the rest of this series, then hopefully we can implement those features. But I hope you guys enjoyed this video. If you did, drop a like, comment what you want to see in future videos, and subscribe so you don't miss anything. The whole playlist will be in the description down below. And thank you guys for watching. I hope you enjoyed, and I will see you in the next one.